Hello, my name is Matthew West. I'm the technical lead for the National Digital Twin programme, and today I'm going to talk to you a little about the information management framework and in particular introduce the 7 circles of information management. The National Digital Twin programme arose from the recommendations in Data for the Public Good published in 2017. Its recommendations included a national digital twin as an ecosystem of connected digital twins to enable better outcomes from our built environment, an information management framework to support the secure sharing of data, and a digital framework task group to provide coordination and alignment amongst the key players involved. One of the first deliverables of the National Digital Twin programme was the pathway towards an information management framework. This set out the technical core for the information management framework as the foundation data model, reference data library and integration architecture. But of course the IMF is going to be much more than that. It's going to include guidance on how to systematically improve information management so that producing data that meets the quality standards required to be part of the National Digital Twin can just become part of business as usual. Now I'd like to introduce the 7 circles. If we're going to achieve digital transformation, we need to do a lot more than just sort out a few issues about the quality of our information management. We need to dig deep and look at the layers underneath and see how those support improved information quality management. So for us, those layers are process model based information requirements, integration architecture, industry data models and reference data, a foundation data model, a top-level ontology, and a core construction ontology. Now, it might look like some of those things are a long way from what we need to do to support information quality management, but the same kind of situation arises in other areas. So if we look at the world of electric vehicles, we see that Tesla is trying to do similar things in a completely different field at the different levels. And to make it work, they've had to work at all these different levels. So if they want people to be driving electric vehicles, there have got to be car reviews that show that those cars can meet the requirements of drivers. There needs to be a supercharger network so that you don't just find yourself high and dry when you run out of battery, and that you don't suffer from range anxiety. You need to have a range of models that you can build. You need to have the platforms on which to build them, and you need to have new battery technology that will actually support those platforms. And then of course that involves mining. So you have to go out into mining as well even. And you find Tesla involved in all of those levels in order to make battery electric vehicles a reality. And we are going to need to look at the levels of information management so that we can put in place all the things we need for a digital transformation. So for information management, the 7 circles are shown here. At the top level, we have managing information on a day-to-day basis, governance, roles and responsibilities, training and KPIs. The next level down, we have process model-based information requirements in order to identify the information required to support decisions taken in business processes. Next, we have the integration architecture, which is the resources to enable the secure sharing of data. Then we have industry data models and reference data, which are the common language used by an industry or sector. The foundation data model, which are the common patterns to integrate data across industries. And the top-level ontology, which are the fundamental categories of what exists. And in our case, that's 4-dimensionalism. And that provides the rigor which pervades all of that we do. And then finally, we have the core construction ontology, which enables us to construct what exists. Now, just because there are 7 circles doesn't mean that everyone's going to be involved in all of them. In fact, quite the reverse. We're all involved probably in the top one, all of us are using information and creating it. But not all of us need to be involved in establishing the process models for the business that we do, and establishing the information requirements to support the decisions. That's the field of process architects. Then at the next layer down, we have the integration architecture, and at this level, it's mostly going to be people who would call themselves as systems architects who are going to be involved with that. At the next level, with industry data models and reference data, these people are often data architects. And then the foundation data model and top level ontology, this is the realm of ontologists. And in the core construction ontology, we need to add to that list logicians. And you'll also notice that the numbers involved at these different levels are coming down quite dramatically as we go down through the different levels. Well, that's about it for the 7 circles. It remains for me to introduce Al Cook, who is going to talk now about the second level, process model based information requirements. Thank you.
My name is Al Cook. I'm a technical member of the National Digital Twin Programme. I'm here to introduce you to a structured approach to identifying information requirements that can be mapped to a model that can support data integration for any application. If we need information to support decisions, why are we so familiar with poor quality information contributing to embarrassment, mistakes, or even being involved in disasters? The larger the undertaking or the longer the information is needed for, the harder it is to keep on top of it, particularly if it isn't clear what information is needed. This presentation covers what it takes to identify information that is required. The National Digital Twin Programme is addressing the challenge of ensuring that data is fit for purpose by adopting an information quality management approach. Working out what information quality is required to support decisions is a key step. I will introduce a methodology for doing this and illustrate how it is based on analysing the activities that are relevant to those decisions. Once done, this provides a solid basis for adopting the other fundamental parts of the information management system shown as the next 5 circles of integrated information management. All the topics covered in this presentation, including the worked example, are available in more detail in the document on this slide and now available on the Digital Twin Hub website. A few words about process here. When I use the term process, I'm not just talking about business processes, important though they are. I am talking about any process that is relevant to what is of interest to us. And I'll use that term interchangeably with the word activity, because the goal here really is to include anything that is relevant to decisions. And by adopting this open analysis approach, we benefit from identifying the role of information about anything that is required to support the decisions involved. So, which leads us to the objective of this presentation. We want to ensure that decisions are supported by data that is fit for purpose. And that leads us to then make some key observations. That firstly, the earlier we can identify information requirements, the more time we have to work out how to satisfy those requirements, and the more opportunity there is to involve that information in any decisions subsequently that need to make use of it. In addition, we want to ensure that the approach that we take for this is cost effective. We're not trying to do information requirements capture to too high a level of detail or to a level that imposes too much cost. But also we want to ensure that we don't have too much data, which gives us a challenge that we have today, which is often it's not clear how to even find the data that's required to support the decisions that we make today. And the third key observation before we make a start on introducing the approach is that it's important to take a life cycle view of the things involved in activities. Each thing itself and each activity has a life cycle, and each thing involved in an activity will itself have a life cycle that might extend well beyond and well before the activity that is of interest when we're doing our analysis. And taking that into account can reveal where information is already created, or is maybe best created, or where else it might be needed. Bearing in mind the objective and these observations, and taking into account the information quality management based 7 circles of integrated information management, we need a methodology that can ensure a consistent view of activities wherever they take place and whenever they take place in the life cycle of what's important to us as an organization, or as an organization involved in a bigger set of activities. So the simple view of this methodology is the first 3 steps of which I'll cover in this presentation, is to identify the lifecycle activities that the organization or organizations perform that's in scope. And this can be helped by looking at some of the core processes that organizations need to perform. Secondly, we need to be able to decompose these lifecycle activities to identify the things that are really involved in them, the participants. And we'll cover participants in a bit more detail, but this can be anything that is materially involved in the activities, each of which may have their own supporting processes. Thirdly, we can then look at identifying decisions that are required for those activities. Typically, this will be at the start or the end, depending on the level of decomposition that we do. And once doing that puts us in a good place to be able to then proceed with our information requirements capture, that is a more information technical activity subsequently. While a lifecycle view is often adopted by communities like systems engineers or project managers, what often isn't taken account of is, firstly, the information and its role in those lifecycle processes, but also that any individual lifecycle process is often supporting an even larger, wider scope lifecycle process. And I use an example in the document of the core processes of a school delivering secondary level education to pupils, for which there is an awful lot of activity going on to support that core process, and the development of an asset in support of the school. For example, the development of a new school building or the extension of a school building. That itself will have a life cycle of its own, but it's there to support the core processes of the school and the wider education system itself, each of which have processes that may require information about activities of each life cycle process itself. While the methodology supports any sort of life cycle process, I'm going to focus here on what I'm calling a built asset system, or any large system life cycle process. And part of the reason for that is that there is a history of working on large asset systems. For BIM, for example, is an area that's received a lot of attention. But also the National Digital Twin Programme is aiming to support the exchange of information relating to large infrastructure systems and the things that are supporting the core processes of organizations delivering, for example, public services. And so looking at large systems that are created to support organizations delivering services, it makes sense to take an objective look at large built asset systems. This slide summarizes the sort of a set of life cycle stages introduced in the document, and there is no surprise here that a life cycle generally has a start, a middle, and an end. And the pattern that I have introduced here is that because the nature of activities changes throughout the life cycle, we can group them into some not prescriptive but some general stages that can be useful to map to, and to map existing life cycle processes to. So I've described the early part, which of a built asset lifecycle stage as being the pre-implementation stage, which may include early business case work, conceptual design work, architectural design, and even detailed engineering design. The next stage is then implementation. So a lot of the costly capital expenditure happens here. Information errors or information quality deficits can have really large cost implications here. And I characterize this as the implementation stage. Then typically the longest stage, operation, is where the service, the asset system is operating to deliver the enable the delivery of a service, and may have to undergo things like upgrades, which will have their own lifecycle processes. And subsequently, most things do come to an end at some point. And for some things, that can be a very long time in the future. Nuclear power plants are one example of this, but rail systems, other transportation systems can have a very long life cycle. But when they come to an end, it can be really important to have information about what they are composed of and what happened to them earlier on in their life cycle. Now, I'm sure many of you watching this video will have come across lifecycle process views relating to agreed processes within an industry, or a specified process for example, the Treasury Green Book for creating a business case has a lifecycle process for its activities. Many BIM related processes have a clear lifecycle definition around them. And in the document that I linked to earlier in this presentation, it includes a mapping to the lifecycle stages that I've mentioned here to those processes. And what is clear from those business processes is that often they are biased towards a particular part of the life cycle of the thing that is of interest to the community that are adopting those business processes. And that can be challenging when we're trying to do a clear analysis of what's really going on and what information is required, particularly if that information falls outside of what is defined as the life cycle process that is being adopted for good reason within a particular industrial activity. So if we want to ensure that information is fit for purpose to support all the activities, we want to ensure that any relevant activity can have and create the information that is required. And this can include a lot of external organizations. It can include functions in an organization or business that are of management nature or supervisory nature, or to enable service delivery. And all of these things, if they work well together, should be supporting each other. And this is where an integrated view of information can really help drive efficiency and ensure that these activities do support each other. As well as supporting other activity layers, as it were, each activity layer will have its own information requirements and be potentially quite complex in itself. An illustration of this, there's more information in the document, but is just taking a close look at the pre-implementation and implementation stages of what we might think of as engineering activity, and that can break down into a large number of activities and require specification to take place early on, may require revision as work is conducted into the implementation phase, and the time between pre-implementation to implementation on a large engineering activity can be months, years, or even decades, depending on the scale of the activity. Adopting a top-down approach can be rather overwhelming. In fact, it will be extremely onerous to do from the top down. And a recommendation is to start small and build out from there. And the benefit of applying the methodology here and adopting the rigor of an integrated approach to information management is that you can start small and build on it, because the consistency is there to allow you that to happen. And so what I thought I'd do is construct an example that was close to something that there's a real world requirement for, because it's always important to focus on things that there's a real need for, particular use cases. So I thought I would look at the creation of brick walls at schools, because there were some issues identified with some school walls that collapsed a few years ago in the UK. In order to do and to illustrate the analysis of this example, I'll be adopting what I'm calling a space-time diagram or space-time map. And it provides a clear representation of what is relevant to our analysis. And the basis for doing this is rooted in the National Digital Twin Programme's foundation data model and the theory called four-dimensionalism that is effectively treating material things as having distinct identity, and that is a spatial-temporal identity. Now, this gives it some grounding and can sound quite abstract and theoretical, but it does result in quite a natural way for us to go about talking about things, because we quite naturally talk about the way things exist and change state. We can use in the real world and interact with quite naturally appear to us like this. What we do need to apply here is the rigor, so that we are not confusing what it is that is being identified as a participant in our activities. And so the clarity of space diagrams can give us that. And there's a simple notation for it in this presentation. So the horizontal bars that are shaded in are participants, and the dotted boxes are associations between more than one participant. And in our case, this is looking at activities. One thing that also becomes clear from space-time diagrams is the boundaries, the start and the end of the activities that we are showing. These are generally where decisions are made. Activities generally start because either a preceding activity made a decision, or there is one that has been made at the start, and generally they end with a decision, and perhaps as a decision required to dictate what happens as any follow-on activity, or to support other activities that rely on, in our example, a brickwork activity. Depending on the level of decomposition that we go to, we may find that we have decisions within the activity, and this is where we will naturally have to think clearly about what we want to capture relating to things that we may not have a detailed definition of, but at least we can capture those within the space-time diagram as shown. If you recall, I mentioned that it's best to use real examples to analyze, to come up with information requirements. And so I decided to take a closer look at a report that was produced by the Scottish Government in 2018. It was a review panel on building standards, compliance and enforcement for Scottish schools. Or generally, the schools were an issue because of a catalogue of walls collapsing due to poor workmanship and poor supervision of it. And the report clearly states the need for improved compliance and improved monitoring of the compliance. So I use this as an example to then look at, well, what does it take to analyze the information required to support the activities of creating a brick wall, something that appears initially as being something like a normal, familiar activity. Well, even making a start on analysis, it becomes clear that You can't make a brick wall without having a number of things in place in order to conduct that activity. You may need a person or persons to do the bricklaying. You may need tools. You may need a mechanical mixer. You may need mortar, and of course bricks. And you need them to be in the right place at the right time and of the right quality in order to undertake the brickwork activity at the school to create the wall that has been contracted for creation at that school. We can now start to add the activities that we can immediately identify as being important to the creation of our brick wall. So, for example, the bricklaying is clearly an important activity. Of course, the bricklaying will require a bricklayer, at least one, presumably. They will need to be selected at some point in advance and arrangements made for them to be able to attend. Perhaps they need the right tools. They may need to travel to the site, presumably they won't live there, and they may need even a permit to be able to be present at the building site. The dry materials that are required may need to be they presumably need to be procured at some point, reasonably in advance, and then will be delivered to site so that they are available to be able to be used. These are all activities involved in the participants earlier in their life cycle before they are involved in the bricklaying activity itself. Then, if we're interested in improving the oversight and meeting the regulatory requirement to oversee compliance better, we will have the involvement of an inspector. This is an important part that the report draws out as needing better information and better oversight of what has been going on. This verification check and issuing of a certificate will require information about a collection of activities, maybe more than is represented on this diagram. And typically, the activity can't take place before a building warrant is issued by an inspector themselves. Minor note here: this offset box here is just showing that the inspector doesn't do some magic move in space-time. It's just that they are involved in the rectangular box that is this brickwork activity to create the wall for a limited period of time. They are no longer part of it. They're continuous in existence there. But if successful, then an approval decision that is made at the end of that verification activity will only take place if the information is available to ensure that it can be issued and the records are there to justify its creation. And therefore we have some information requirements relating to this final inspection activity. What does the inspector need in order to undertake the verification checks? The inspector may also need to take pictures or make additional notes and comments before a certificate is issued. And this decision here will be done to support other activities, perhaps in the compliance area and further checking, and maybe to create other compliance documents relating to the rest of the school itself. So thinking back to our engineering activity lifecycle model, the one that we illustrated in a top-down sense earlier on, we can illustrate that a number of the activities on the space time map that we've got here relate quite easily to different elements of the activity lifecycle model, from stakeholders and suppliers to core engineering activities. And this is just a small subset of what may be the total set of activities relating to why the wall's needed in the first place, which may be part of a new school complex, a new building, a rebuild, or remedial work, which will involve, in all likelihood, a lot more than just the brickwork activity itself. Another sort of step up into the engineering activity lifecycle model is just looking at how individual activities map into these sort of the business groups, the service levels illustrated earlier on, and this is simple view showing the role of the technical specifications just illustrates that the complexity of the or the dependence on some of these things that are produced early on in the life cycle and how cluttered it can become unless there is a good clear basis on which to present this. So it is easier to start with a space-time map and map back to these sorts of views than to start with a more arbitrary view and then try to construct a space-time diagram. So having now introduced a methodology and gone through an example to illustrate how to go through analysing an activity, identifying its participants and identifying the decisions of interest in that activity, we can now take stock of the methodology as it was introduced early on in this presentation. So we have introduced a generalized approach to identify the decisions that require information through the use of a life cycle activity model, the scope of the activity model being based on what it is that we are wanting to apply it to, from very small scale, perhaps initially, to large scale activities in the limit. We can do that through the identification of participants in the relevant parts of the life cycles, identifying their life cycles themselves, and looking at activities that are relevant so that we can identify decisions that are relevant to the analytic task, and do that to a level repeatedly so that we are getting to a point where we're happy to then move on to a more technical activity, which is looking at the information requirements capture itself that will be subject to another presentation. Might be worth reflecting here that the National Digital Twin Programme was founded in order to help to generate a use of data that is useful to the UK and those operating within the UK's ecosystem of suppliers and public services. And as a digital twin, this analytical approach takes it about us as close as we can reasonably get to actually having a faithful representation of the things that we have a real need to have information about in data. The methodology in this presentation itself is part of an extended methodology, which does go into the more detailed realm of mapping to a data model and identifying in detail what the information about the participants should be, and how to specify them, how to do a gap analysis, comparing what is needed with what may be available, or what tools that are in current use or likely to be used, how close they may get to the information requirements. Remember, information requirements do have to be agreed at some point, and part of that process of agreement should reasonably involve a gap analysis, looking at what is currently done, and then an approach to then deciding how to conduct information management based on those information quality requirements. And I'll be covering that in a subsequent presentation. Thanks for your attention. I hope you enjoyed the presentation. Please don't hesitate to leave comments and questions on the DT Hub.